Hi everyone, my name is Zafar Saeed and I'm going to present the impact of negative sampling for link prediction tasks, a broader perspective. The research study is funded under the FAIR project. This study focuses on addressing the challenges like cost, constraint, and quality when integrating inputs that underscores the need of complex reasoning in symbiotic AI systems. This work is related to exploring knowledge-intensive components for knowledge-intensive tasks in knowledge graphs. In order to cope up with the incompleteness in knowledge graphs, the graph embedding methods are used because they scale. In graph embedding methods, usually a random corruption method is adopted to generate negative examples. So these random corruption methods may introduce false negatives or low quality negatives that can degrade the knowledge graph embedding performances. The absence of extensive study to investigate not only the impact of negative sampling method but also elaborate negative sampling methods for being accurate model in terms of quality, constraint, and cost. So there is an absence of such kind of studies, and also a lack of clarity on which negative generation method is best suitable for building effective models satisfying accuracy, quality across domains and data sets. So main motivation of our study is knowledge graph embedding methods. Those aim to project nodes from a graph into low dimensional space where similar nodes based on their relational properties are positioned closer together, facilitating machine learning tasks to use embeddings as a feature space. Well, a closed word assumption makes it easier to generate negatives, though it comes with a downside and might generate statements that are sometimes not useful or even incorrect. For example, the statement in knowledge graph that says Da Vinci painted Mona Lisa, so consider this to be a part of knowledge graphs. So the random corruption method can end up generating some meaningful negatives or meaningless negatives, or in fact incorrect negatives at the same time. So there is no guarantee that the produced negatives are in fact useful. So this study is derived from the problems related to random corruption with the goals to identify and characterizing the negative sampling methods, and also investigating if the random sampling techniques are as good as any other state-of-the-art approaches. And we need to empirically evaluate the impact of negative sampling methods on variety of knowledge graph embedding methods. Our experimental design involves extensive experiments with the 13 number of embedding methods that are widely used in such scenarios, with the approximately 12 number of negative samples, and there's variety of number of negatives against each positive that we are going to test on 5 different data sets. So these extensive experimental design may require to do well over 5,000 experiments. These are just the sample results we collected against relational samples. There are a number of negative sampling techniques, as I have mentioned in this table, out of which these results are against the relational sampling with WordNet 18 datasets. So this table reflects their comparison, and also adjacent to these there's a line chart for visual comparisons. So still we have a long way to go with the total over 4,000 number of experiments to be conducted. So with these experiments and results and analysis, in the future these analyses require some systematic approach for comparison, performance comparison of negative generation methods based on the criterion on which we have segregated these approaches into static and dynamic approaches. So the segregated comparison could be based on translation-based methods and similarity-based methods and neural network-based methods such as KG-GAN and KG-BERT. We also aim to check the impact of the number of negatives against positives, and also of course training time based on negative sampling techniques, because we also need to make these embedding methods scalable, since the knowledge graphs are mostly enormous and huge. So These methods for the machine learning downstream task have some significant applications, but not limited to e-commerce recommender system. For example, recommender systems, drug side effects, and co-authorships, and citation networks. The results could lead to a conclusion if it's worth exploring negative methodologies and keep focusing on introducing new and complex approaches that may improve the performance of knowledge graph embedding methods. So this was our study so far, and thank you so much for your attention.